Hello everyone, and welcome to the NSTA web seminars where you can find live interactive learning at your desktop. Today's seminar is titled Revitalizing Elementary Science Through 3D InterAgtion. My name is Carolyn Moore and I will be moderating today's program. Our presenters today are Audrey Harmon, the state contact for Oklahoma Agriculture in the Classroom, Tammy Maxey, a program manager for Virginia Agriculture in the Classroom, and Deborah Spielmaker, a professor at Utah State University and the team leader of the National Center for Agricultural Literacy. Also with us this evening from a teacher panel are Amber Bales, a third grade Oklahoma school teacher, Jessica Pittman, a third grade Virginia teacher, Tiffany Porter is a learning coach and STEM coordinator in Utah, and Deborah Steen teaches 4th and 5th grade science in Tennessee. Debbie is going to start us off this evening, so I'm going to turn the mic over to you.
Thank you, Carolyn, and welcome everybody to 3D InterAgtion. Tonight we're really going to try and contextualize science within the topic of agriculture. And so to kind of get us started with that interactive approach, take a look at this source search for our first interaction. And as you can see, lots of different images here. Use your tool to, if you think this item comes from a store or a factory or a farm or a natural resource, grab that tool and just put a click on those items that you think come from whichever one of those resources. Carolyn, you may have to give me some more instruction, but we just did it, so hopefully everybody can follow along.
Thank you, Deborah. So the toolbox is available to you again, and you go all the way down to the bottom icon where the clip art is. I see you're finding it. Good job, guys.
Lots of clicking going on there, and it looks like we could go on, and these would be pretty much covered. But this is actually a lesson plan titled Source Search that we have on our website, which we'll introduce you to tonight. And it's one of the first things that we can do to begin our interaction. What is it that's around us, all around us, every day, at least 3 times a day, and all the things that maybe we don't consider just our food, but the things that we use every day around us that come from agriculture. And in this case, there's a lot of little happy faces that say the farm. There are some stars, factory, and there's a plus symbol for store and then natural resource. So in this lesson, the way it's set up is it's actually a relay race, and kids take the individual photos and they sort them in a relay race into 4 tubs. One titled store, one factory, one farm, and natural resource. And then as a debriefing, as a teacher, you come and you have a discussion around, wait a minute, I just asked you what the source is of all of these different items. And if you really think about it, the store and the factory is really not the source of any of these items. Really, these things are grown or they're mined. And ultimately, you can take those tubs or those bags that you've had students sort into, or little, sometimes I've done it on tables with little baskets, and you can say the farm is using natural resources to develop or create these things that we use in our lives every day. And to get these things to us, whether it be the coat or the V8 juice or the milk, there's a lot of science, technology, engineering, not to mention business and economics. So your first interaction here is, wow, it's either grown or it's mined. And always have kids try and guess, you know, what is it that might not be grown or mined, and we have a really good time. And I'll just draw a couple of attention to a couple of these items, like the soda here, which is covered with lots of stars from the factory. Well, in fact, sometimes we turn over the label and we look at it, we see the first ingredient, and the first ingredient is water. So I suppose Dr. Pepper, Coca-Cola might be part of a natural resource because it's water. And then, of course, water is in that same way. We talk about it in terms of the factories where we put things together, and the store is where we go to pick it up. So that's our first interaction, and I guess we don't need to clear that or anything, Carolyn. We can just move on from there. As we get into the idea of science and all the different science in those types of things that we just looked at, science has really been defined most simplistically as a way of knowing. And the focus now with the next generation science standards and 3 dimensions of learning is a focus on how we know. For quite some time we were going through with inquiry-based learning, and many of you probably use that method in your class. In fact, inquiry is still a really important strategy. It goes along with, you know, project-based learning and those kinds of things. But there was kind of a tendency with the inquiry to just focus on the activities. And so in the next generation science standards, you start hearing things about phenomena and looking at the big picture and having the big overarching look at how things are working within context. So it's a focus on how we know. And for example, I have this little soil sample sitting right here. And if I said to you, what might be in this soil? You know, how would we look at it? How do we know what's in the soil? What's our way of knowing about soil? How can we find out? Well, we're going to do some observation, and we're going to probably do some experimentation. So if I went back to that, okay, observation, this is a pretty good clean thing of soil. In fact, it's real clean. If I went out in my yard today, there'd be a lot more little sticks and pieces of bark and things like that, leaves this time of year, of course, and grass clippings. So we have this close observation, and many of you may have done this with a hand lens. And then you may have also tied that into things that are living and non-living, because sometimes in a sample of soil, obviously there's things crawling around and there's worms and that kind of thing. But oftentimes we're like, what is really the composition? What are we really taking a look at? And so if you go out into the woods or the garden or the field and you collect these different samples, depending where you are in the world, and we have somebody joining us from Spain, yay. I've been there, it's a really neat place. But different kinds of soils. I'm in northern Utah, I've been in southern Utah last week, and we would have a lot of red soils. And Audrey's from Oklahoma, and she would also have some red soils inside of here. But these obviously look different, and how would we know what the different components are inside of each one of these soils? So we do some experimentation. First is the observation, and this is really just like, how are we going to put that? What is that kind of guessing thing that we're looking at? How can we turn that into this understanding of three-dimensional science? So based on your observation, you look at it and you say, I see some small sand particles, some air, some water, organic matter, maybe some dead grass and insects, or all of the above. And so this is actually a question that you can go ahead and use your question mark on, and then Carolyn can show us the overview. But based on your close observation, what would you say the answer is here?
So go ahead and use that polling button at the top underneath your name. It has a letter A. I'll give them just a couple more seconds, Deborah, and then I'll lock the poll.
Now, most of you are saying and getting, you know, all of the above, all those things, because Deb just talked about them. But if you take a look at that one that oftentimes students really struggle with, especially if it's a dry sample, they'll say, well, I don't see any water in here. In fact, going back to that very first slide that I had, there was no water in there. And yes, small sand particles is what we saw in the large picture. But when you look closely inside of the jars, you could actually see the grass and the twigs and all of that sort of thing, leaves, and the mineral matter. But students sometimes like, air, what do you mean there's air in there? And so sometimes you say, well, how can we investigate that? And there's another test called, to figure out what your particle size is, you add water into these jars. And the first time that this phenomena was presented to me was by a fourth grader who observed, as I was pouring water into the jar, why are there bubbles coming up? Well, the bubbles are coming up because there's air in the soil. And that was, oh, an aha moment, I get it. And then we went on and shook it and saw the different particles shake out, sand being the heaviest, going to the bottom, and silt, clay, organic matter. And all together, those might be called, would be called a loam. And then kind of in suspension, eventually this will settle out, and that's your clay layer, and this floating stuff is organic matter. So that's one of the ways we can experiment. We looked at it, we first did observation, and then we did a small experiment to say, yes, indeed, that in fact is what we see inside of soil. It's a way for us to know there's water, there's air, there's organic matter, and soil particles. And by the way, that little chart right here, grab this little guy right here, that little chart has oftentimes been used as the ideal soil. But of course, that doesn't really exist. The ideal soil is not really there. It's it's just what all the different components. And if you live in an area with really high organic matter, of course, yours might be, at 10 or 15%, and those are the kinds of soils that we look for things to grow in. And that leads to a completely different conversation about phenomena like which soil is best, or why is something growing better here as opposed to something growing better over there. I've used this term phenomena a couple of times, and it's going to come up a couple more times in our conversation tonight. But really in the three-dimensional learning and phenomena, these are some terms in the next generation science standards that teachers are being asked to use. And the greatest thing about phenomena, even though it sounds like a big hard word when kids are trying to say it, is that they are probably the best at giving us what is phenomena. They are the kinds of questions where they say, why is it like this? Or why, for example, I had a 5-year-old ask me, why are the snails on this side of the house and none on the other side? Well, so what's different about this side of the house? Well, it's kind of wet over here. So they're already at age 5 and 6 doing their own investigation of phenomena, and they come up with these great kinds of questions. And I think that's the thing that leads us into more of the science instruction. We'll get you into the three-dimensional learning. All right, so that's just a little bit about soil. Oh, with a follow-up. I love soil and I love seeds. I'm passionate about both. And for any of you who are really interested in the jar test, when you put the soil samples and start shaking them out, this shows you what happens to them over time. And at day 100, you still have some settling that's gone on. In fact, these are the tannins that are left inside of this particular sample. But they settle out over time. And then finally, you see that clay layer. Clay layers can sit inside of a soil sample for many months before they settle down. So that's a good way to explain the different properties of soil, some using our observation and experimentation. And I just wanted to kind of present that right at the beginning of our webinar tonight to give you an example of what we're talking about in terms of having an interaction. To have that question, to be observing phenomena, and then doing some experimentation, observation, to come up with how we know, which is what science is really looking at. So how we know, that is that constructivist learning theory. That is the idea that we construct our knowledge, that learning is active, it builds on previous knowledge, and we are actively making associations, and there's new learning that can be compared to prior knowledge. The second bullet here, built on previous knowledge. This is something that with inquiry-based approaches, some people have been very critical that they don't have enough previous knowledge to actually do the experiment or to really understand the concepts. And so this is where the need for a teacher comes into play, that idea of making sure that you giving them the necessary tools to facilitate their learning by making it very active, making it how come, bringing it back to the why, and having that big picture. So this constructivist learning theory is very much a part of the next generation science standard. It's very much a part of three-dimensional learning. And in fact, the connections to the natures of science, which is right at the beginning of the science framework, and I'm not sure if all of you can see that small font there, but for primary school or K2, science knowledge helps us to know about the world. That is the way of knowing. That's kind of the standard, if you will, for the connection of science for that age group. Elementary science grades 3 to 5, a little bit of building on that, connecting to some prior kind of understanding and building that scaffolding, that progression of learning. Science is both a body of knowledge and process that add to new knowledge, and then science is a way of knowing that is used by many people. And so tonight's presentation is really geared toward a K6 group, and so we'll really be focusing in on these areas. But as a team leader for the National Center for Ag Literacy and our folks that are joining us, my colleagues here, Audrey especially, and Tammy, members of the National Agriculture in the Classroom organization, we have resources that are K-12, and in fact we'll be doing 2 other webinars this fall, and the next one will be for middle school, and then there'll be another one for high school. But we will focus most of the content here on three-dimensional learning for this K6 group through this presentation. All right, you may have seen this little logo here. If not, the URL is right here. The nextgeneration.org 3 dimensions. The three-dimensional learning, and we're using agriculture as a context for that tonight. Soils was just our big kickoff, and we have a couple of other activities we'll share with you. But science and engineering practices, behaviors and skills, cross-cutting concepts, and core disciplinary or disciplinary core ideas are these three-dimensional learning. Sometimes people say 3D, not quite right. It's the 3 dimensions of learning. And so you're looking at, in science, the engineering practices, the behaviors and the skills, and those kinds of things. Science would be differing in that it really involves the formulation of a question that can be answered through investigation. Engineering design, which is really something that's definitely needed in all of K-12, is bringing a little more engineering into the classroom, involves the formulation of a problem that can be solved through design. In agriculture, we always are trying to fix a problem, and we always have to understand the science to make that engineering to formulate the problem and come up with some sort of solution. So this first dimension here, the science and engineering practices, is one that is quite evident and obvious in the instructional resources that we provide to teachers who want to use agriculture as a way of knowing science. Cross-cutting concepts, this second bullet here, is concepts with application across the science disciplines. And so we're looking at things like patterns and cause and effect and scales and proportion and quantity and models and systems. And again, when you start looking at big things like weather and even soil type systems, it is a really good way to put, and being able to grow our food, clothing, and our shelter. Agriculture becomes that interaction for these 3 dimensions. And then third, the disciplinary core ideas. This is really STEM, although that word isn't in the Next Generation Science Standards like that acronym. But this is the integration of those core disciplinary ideas in the actual science disciplines of biology, of the life sciences, physics, and chemistry, and the technology, engineering, meaning math, all together to these core disciplinary ideas. So what I hope that you'll get out of tonight's session is, if you look at the way we've contextualized some of these lessons, is, oh yeah, I can see how all of these different practices are being contextualized with these ideals of knowing about food, clothing, and shelter. And these are the kinds of why questions that students have. These are the wonder, like, well, how does that happen? Well, where did this come from? And they're very, oftentimes kids know that food comes from the farm, even though we like to say sometimes they don't. They kind of do know that. They just don't know the process. They don't have the way or the how that to explain what's going on. So if that seemed a little confusing, the practices and core ideas and cross-cutting and ideas and hopefully it's not new to you. It's been out, since 2013. Just keep calm, and we'll continue to unpack some of this and give some examples as we roll through these slides. So on science and engineering practices, these are the kinds of, these items here: observation, inquiry, problem solving, building models and systems, collaboration, design, critical thinking, creativity, and communication. Those are the practices that you're looking for in instruction that will get at the science and engineering. And so oftentimes when we're thinking about, they really should know about this topic or this overarching system, you're looking for ways to incorporate these types of practices. And in fact, that's what we try to do with the different resources that we'll share with you. And the teachers who are our teacher panel tonight have done a great job in their own schools with making sure that these different 3 dimensions of learning are part of what they do in their classroom. Crosscutting concepts, already mentioned these: patterns, cause, effect, scale, systems, energy, matter, structure and function, and stability and change. These, again, are some things that each time you're going through an activity or trying to meet a learning outcome, we're looking for ways to make sure that you are explicit about those types of concepts. That is really what's the overarching. That's what's going to be transferred. That's what they're going to be remembered and retained, and hopefully make them a lifelong learner and a problem solver. Disciplinary core ideas, mentioned those. The ideas of broad importance, key tools for problem solving. They relate and are relevant. That's critical to students. When the example is really relevant to them, food, clothing, shelter, it makes it just like, oh yeah, this is something I use every day. They really connect to that. And then building in a learning progression to scaffold that learning and making those connections so there's some retention of the content. All right, I'm going to be quiet and step back now, and we want to highlight a couple of our teachers here. We have 2 videos, and the next 2 videos, we have 4 total tonight, but we'll do breaking them up in 2s. The first video is of one of our teachers who's on our panel this evening, Tiffany Porter, and I'm going to turn the time back to Carolyn, and she'll tell you what to do, but basically I think you're going to jump out now and go to a browser window and watch these videos just to see how these 3 dimensions of learning in the context of agriculture have been played out in the classroom by a couple of our teachers.
Thank you, Deborah. So I have just put in the chat window the URL for you to click on and go on over to your computer and watch that video clip. And Deborah would like you to put any questions that you have as you're watching the video in the chat window. So we'll see you back here in a couple of minutes. Florence, you might have to push the button for it to start playing. We'll give them just a few more seconds, Deborah, to come on back. I'm not sure if you saw that one question that Robin posted. We have one question so far.
I see the question, and it's really for Tiffany. Where do the proceeds from the sales go? How much did it cost to build the greenhouse? Tiffany, do you want to comment on that?
Just click on the talk bar in the audio video window, Tiffany.
Sorry, I lost it for just a second. Yeah, the proceeds go to providing seeds and soil, fish food for the aquaponics, just in operating costs for the next year. And the greenhouse cost about $25,000 total. We had a lot of stuff donated and a couple of materials and mostly labor donated through the community and parents, even students.
That's kind
Thank you, Tiffany.
I was just going to say that's a little bit of a pricey greenhouse, but I've seen them done for much less. You got pretty lucky there in your community for that much support. The greenhouses can really range depending on size and how you cover them and how much of the season and heating and cooling and all of that. But I've seen them with schools more and more, some low-tech, some high-tech.
Yeah, ours is a little more high-tech with a lot of, I think that the main cost was the aquaponics with the big fish tanks and a lot of fish, and that system ended up costing quite a bit.
There's one more
Kevin has a question. Go ahead.
Do you see it, Tiffany? Do your STEM journals involve?
Ink pens to keep students from erasing. No, we don't. We a lot of times the kids will be gluing things into their STEM journals, like graphic organizer type things. We go through the engineering design cycle quite often, and they'll glue that right into their STEM journal to keep track of, you know, asking questions and revising and that type of thing. They'll glue in tables to keep track of data, but no ink pens. We let them use pencils and just make errors that they need to, I guess.
One more question from Rose. What were some of the challenges you faced in maintaining this program?
Some of the challenges would be probably maintaining the actual greenhouse and things out there. You know, the tanks need to be scrubbed. Our area is quite warm, and so we have some algae issues that we have to work on. But pretty much the greenhouse itself is self-functioning, if that makes sense. So we have solar panels that heat, that charge the batteries to run the pumps out there. We dug down to do geothermal cooling and heating. So pretty much we have a little sprinkler system that runs itself, and the aquaponics runs itself. So there's not a lot of maintenance involved. Vandalism, we do have the greenhouse area fenced. And we have not had, knock on wood, any vandalism issues. We have a part of the grant that I received from the state of Utah to build the greenhouse. We were able to put in a security system, a little camera with some security system with that. But we have not had any issues with vandalism at all, knock on wood.
Okay, well, some questions can continue to roll in because we have a couple of other teacher highlights here that we'll have throughout our slide presentation, but I'm going to go ahead and go to the next one. The next slide here is Amber Bales from Oklahoma, and her video also talks about what she did as a National Award winner, but again, it highlights the way that you can integrate and contextualize your science within agriculture. And I have to actually give a shout out to her because her, when she presents that she was really looking for something new to do, revitalize her teaching, it gave me the idea for the title for this webinar. So thank you, Amber, and I think we can go ahead and watch your video. Carolyn will paste the link again into the chat window. If you just click on that, hopefully it opens a browser and start it, and we'll come back and keep on going with our presentation.
Thank you, Deborah. This one's about 3 minutes long, so the URL's in the chat window, and we'll see you back here in 3 minutes, and I'll set the buzzer. If you're watching this as an archived webinar, everyone is looking at the video clip, which is about another minute and a half before we come back. So as you're coming back, feel free to write any questions you might have or comments in the chat window.
I just have this one question I've posed up down here. Did the students do the presentations? Is this something that they did themselves in the classrooms?
Presentations as far as in the cafeteria, yes, they talk about those. Maybe need a little bit more information about presentations, but yes, when we go in the cafeteria, they're able to assist. We also have we buddy up with the pre-K, and so they definitely do presentations and talk about fruits and vegetables with our pre-K buddies.
Somebody's talking here about the integration of reading with STEM, and that is something, obviously, if you're an elementary educator, reading, writing, arithmetic is still really important, and the way you're going to probably get this accomplished is by making sure that it's integrated, and I think that your video had a great example of how that can be done. You can continue to post some questions here if you have them, but I think we'll move on because we saw quite a bit here, and if there are some, we'll come back to them, and Carolyn can let me know that we have some more questions. All right, well done. Clear as pea soup, what they did, clear as how to integrate the 3 dimensions of learning. But one of the things that was mentioned in Amber's presentation is that she used the book called Who Grew My Soup, and we'll talk about that a little bit more in a minute. Any other questions that we might have from the audience at this time? We'll just keep calm and unpacking. Feel free to post them down there as Carolyn had, and if you need to, I'll try to monitor them and make sure that I pause, and also the other presenters, Audrey, obviously, if you see something there, Tammy, that we need to answer, I'd rather answer it before it gets too far away. Otherwise, we'll keep calm and continue to unpack these 3 dimensions of learning, or 3 dimensions of three-dimensional science practices. So on our website, this is the agclassroom.org website, and this is if you go to agclassroom.org, and in fact, you ought to have another browser window open just like you did for the videos, and go there because we're going to be using this throughout the evening to search for a few things. And one of the items that was used or discussed in that last video was Who Grew My Soup. So if you went and you searched on that topic and you put into this agclassroom.org website, which is noted right here, you would type in this bottom box right here, just the word soup. And if you type the word soup in there, you would find the lesson plan. In fact, I've got a little screenshot of it. You probably can see this on your browser window right now as you can scroll down through. When you search the word soup, you come up with these other lessons here, and the third one down, or the second one is for grade 3-5, and then Who Grew My Soup for grades K2. The reason there are 2 different levels here is that we've matched them to national standards, and we've aligned them with Common Core standards, and we've looked at them in terms of the National Ag Literacy outcomes. And so we've made adjustments to show how they meet those different standards with those different grade levels. You'll also notice that there are several companion resources that have the word soup here noted at the bottom, and some other multimedia kinds of things. And so this particular lesson was one of the ones discussed in Amber's presentation. I'm going to hand off now to Audrey, and she's going to walk you through the Who Grew My Soup lesson plan as you can see it. And you'll be able to scroll through and look at it in real time while we're only able to show you a static shot here through the webinar. Audrey?
Okay, everyone. On the National Matrix, we have the lesson pulled up here for you. And the Who Grew My Soup book is one of my favorites. If you do not have the book, you can purchase it on the website for just $7. So you can go under the suggested companion resources and be able to purchase that book for your classroom. It's an amazing book. It has lots of rhyming, onomatopoeia in it. We also have the author reading it for you, so that's one of the links that you can find. And there's another video of the author discussing his life on the farm. So those are both great opportunities for your students. And if you're looking down through the lesson, you'll find different ag facts for your students. So this is a great way to engage them and to find out what do they know about the different foods that are involved in making soups. So for instance, the oldest known vegetable is the pea, or that frozen foods were first introduced in the 1920s. So just ways to engage your students. Amber mentioned in her video, this is one of the books that she mentioned, and then she also used the stone soup recipe. So many of the teachers I know in the fall are doing stone soup, and this is a great connection to go along with that. All of our lessons have background agriculture connections. So if you're on the National Matrix and you're looking down through the lesson, as Deb suggested on maybe a different browser, you'll find the agriculture connections for this. So some interesting facts for your students. One U.S. farmer produces enough food to feed about 155 people worldwide. And so that's something important to talk to our students about. But a lot of times when we talk to them about agriculture, we talk about farming. And it's important to point out that there are other careers beyond just farming that are involved in agriculture. And agriculture actually employs more than 24 million American workers. These jobs include things like harvesting, shipping, processing, packaging, and so those are jobs and careers that we want students to think about so that they can see the importance of agriculture to their life and possibly career choices for the future. And then also for students to realize that even though they might go to Walmart or a grocery store to purchase the foods, that they're actually grown on the farm. And so this book is about a young boy named Phineas Quinn, and his mom's made vegetable soup for him, and he decides he's not going to eat it because she's always told him, don't put that in your mouth, you don't know where it's been. So unless she can tell him where his food came from, he's not going to eat it. And suddenly a hot air balloon swoops down, and he's taken on an adventure to learn where the foods are grown that's in the soup. So it's underwritten by Campbell's Soup. The farmers that are represented are actually farmers who grow vegetables for Campbell's Soup, and come to find out Phineas does enjoy the soup and ends up wanting to eat it. So that's how the book connects to agriculture and to the background knowledge. And then some activities that you can do with that, I think Deb's going to talk about one, and real quick before she gets to the farming in a glove, we also have the Who Grew My Soup with a wheel on it. And so it's a fact wheel. So you can put students into groups, and they can do some research. They can find out facts about tomatoes or green beans or celery. So that there's a wheel that's available on the website, and you can print it off for your students and let them learn some fun facts to connect the farm to the food that they eat. And I'm going to turn it over to Deb now.
Yeah, and Audrey just talked a little bit about that wheel as part of an integrated way to really connect them to that, what they're reading, and what really happens in terms of understanding agriculture. There are other companion resources for that particular book, and in fact, when you search, there was one of them at the very bottom that was called Farming in a Glove, and this is one of the more popular kits, if you will. Farming in a Glove is really just a food handler's glove where you have a cotton ball inside of each one, and then you can have 5 different types of seeds, or if you want to do some sort of different kind of test with the seeds, you can put the same seed and give them a different treatment in each fingertip. This is something you can go down probably to the cafeteria, you can get a food handler's glove, you can build them yourself, but just to know that all of these resources they make them very available to you. You just click on it, you can add to cart, you can check out, and in the mail is going to come one Ziploc full of all the cotton, all the little gloves, and all the seeds you need to have to be very successful in doing this kind of an activity with the reading of the book and bring together the science part of it with the social studies part of it with the career pieces that she was mentioning. So I just wanted to highlight, in addition to the instructional resources, in addition to that wheel that maybe you scrolled through in that lesson, in addition to the standards that we've applied these to, we've put together kits where we thought this might be hard for a teacher to get, made them very, very low cost for you to just add to cart, have them show up at your school so that you'll be ready to go to be successful with that lesson. Back to you, Amber.
Okay, so I noticed that some of you were asking where do we order the book, so I just gave that URL in the chat. And then also I just added the URL for the movie. So this is the author reading the book and then also talking about his life on the farm. So those URLs are both in the chat window for you now. And then we're going to move on to another lesson. I was looking to see the comments that are coming in. Yes, the book, The Who Grew My Soup, is fantastic with tops and bottoms. So that's another great book to connect it to. That's a great idea, Tiffany. So the next lesson that we have for you is the case of the missing pumpkin. So as fall is approaching quickly for us, we start to do many fall activities. And this lesson is one of my favorites whenever I was teaching. My students love this one in the kindergarten classroom and all the way up through the elementary. This is a great way to teach about decomposition. And so talking to your students about, you know, how many of them have carved jack-o'-lanterns, and then what do they do with the pumpkins when they're finished, and connecting them back to agriculture. So talking about why do we grow pumpkins, what are they used for, and then what happens to them. So as we're looking at the science of the pumpkins, we can go on to the lesson, the case of the missing pumpkin. And as you're hopefully looking through the lesson on your browser window, I'm going to point out some of the highlights for this. Under the procedures, you're going to find some different questions to go along with the book Pumpkin Jack. And this is where you really get into the science behind the books and behind the pumpkin activities. Have students plan and experiment to see what do they think they need to do to be able to see decomposition happening with the pumpkins. So a lot of times we as teachers will set up an experiment for them, but let's let them plan it and ask them questions and see what will they need, what resources do they think they'll need, and then we offer some suggestions for you. So one of them that's in this lesson is bringing in an aquarium with some soil and putting the pumpkin in it, and then being able to monitor it to see how many days does it take for the pumpkin to really start to decompose. Another way that you can do it is to use a gallon-sized pickle jar, glass pickle jar, and just cut the pumpkin up into pieces and put it in that pumpkin jar or the gallon-sized jar. And in just a few days, you'll see decomposition happening. You don't even have to have soil in that one. And then students can collect the data and analyze it. They can look at does temperature affect the decomposition? How about light? How about more soil, less soil, and things of that nature? And really see science happening before their eyes. And so that's something that students enjoy. Another activity that we have is sprouting a pumpkin seed. So oftentimes we'll cut open the pumpkins and count the seeds inside, maybe for groups of 10 or counting to 100, things like that. But with this one, just leave those seeds right inside the pumpkin and fill it with potting soil, and you can actually sprout the pumpkins inside the pumpkin shell. So that's fascinating for students. They love to see the pumpkin growing inside of the pumpkin, and then you could transplant them later to actually get the plants to grow and to start producing pumpkins. And then this is a great way to teach life cycles, so you can move on once they're understanding the concept, and you can teach the life cycle to them. And along with that, we suggest a model for them. So this is a simple paper plate model. The templates are on the website for you, so you don't even have to be a creative drawer. They're already there for you. And then see, can the students model, can they explain, can they go through the different steps of the life cycle? to understand that before the pumpkin is orange, that there's actually a yellow flower first, and then a green pumpkin, and then finally the orange pumpkin. And then they can take it all the way through to the decomposition. With this lesson, you can also do an enriching activity. So along with our lessons, we don't just have the background information or the experiments, we also have enriching activities. So one of them that's on here is making a pumpkin bird feeder, and there's many different ways that you can do that. One that we like to do is to slice the pumpkin into slices and then poke a hole through it and hang it with some yarn and poke bird seed into the side or the pumpkin seeds into the side of the slices. So a really quick and easy way to make a pumpkin bird feeder that your students can then see wildlife and also enjoy the whole life cycle of a pumpkin and not just a glimpse of it.
So hopefully now you can see with the those last two examples, the Who Grew My Soup lesson and the pumpkins, the case of the missing pumpkins, you can see that there are these opportunities for covering and being explicit about the three-dimensional learning. Science and engineering, I hope that you're able to see that they look at and, you know, build just the last slide alone, building different models, maybe creating a theory about why, you know, students very often ask, why is this pumpkin green? If they've never seen them growing in a garden before, and as you pull them out, in fact, these images, these various, the seed, the leaf, the flower, the green pumpkin, the orange, are all tucked inside of this paper plate stapled together. And so I know teachers who, you know, maybe once a week they pull out one of those different elements and talk about what's going on in each one of those as a model for how it's going to take place, what is the cause and effect. And they pull out the green pumpkin and are like, why? Why is that green? And they get to have a conversation about how that pumpkin matures and how it will change color and that kind of thing. But that particular modeling activity, I hope that you'll see that there's some science and some engineering, obviously, within some of the things that were talked about in the soup book. And then the cross-cutting concepts, as you look for the similarities, the proportion, and building models. And then finally, the disciplinary core ideas, where there's science disciplines are linked in there because you've had to look at some of the biology, the life science, and some of the physical science. And we'll be talking a little bit more about matter and those kinds of things as we get down into a couple more lessons as we move through. But I hope you're starting to unpack some of the things you're seeing and being able to apply, yes, I see what this is, and where I can be explicit about these three dimensions that are three-dimensional learning. All right, we have another couple of video posts here then from two other teacher winners. This is Deborah Steen, and I think we'll go ahead and post her video link in the chat box, and you can watch hers. It's 2 minutes, 41 seconds, and then we'll come back. And as the video is rolling, if you have any questions, go ahead and post them in the chat box. She'll answer those, and then we'll also see Jessica Pittman's right behind that.
Thank you, Deborah. I have the URL in the chat window for everybody, and I've set the timer. See you back in a few minutes.
I'm seeing a question for you, Deborah, about, I'd like to know more about the periodic table connection. So do you want to talk about that a little bit?
Just click on the talk bar in your audio video window.
Okay, now can you hear me?
Yes.
Yes.
Okay. Sorry about that. I learned about this in Ag in the Classroom conference last year, and what it is you take like a manila folder, and on one side you have the human skeleton, and you place the body parts on the human skeleton, and then on the other side you have like cornstalk plants. And in this activity, it told you the different things that the corn needed to grow, you know, magnesium, potassium, things like that. And then on the skeletal side, then it has a paper that goes with it that tells you what your different parts of your body need to function. And so then you place those, you make the connection on the plant side and how you use that in your body, how you use the magnesium like from the corn, and how you would use that in your body. And you glue it or write it on the skeleton. So all of those things come from the periodic table. And we have a periodic table there so they can find the elements on the periodic table.
Very good. I see a second question to you here about growing plants in small spaces. Wants to hear more about the PVC and hydroponic setup.
Okay. The PVC pipe is something that we started last year, okay? I see all these expensive things in the book, and I don't have a budget that will do that. So what we're doing, and we're going to try it on a bigger scale this year. My STEM teacher is going to help us do this. But we take the big round PVC pipe, and we took just like a box that you would store things in, you know, and then we took that and we put the pump in the bottom. We ran pipe up to the outside, and we drilled holes in our big round PVC pipe. It was like I think 6 to 8 inch diameter. And then we went to Lowe's and we bought the little connectors to fit in our hose that we drilled, and that's where we put our plants in. We planted our plants in there. And then at the top we put the hose in, and I bought little sprinkling things that you can get, you know, from your farm, like Farm Tech, and I think mine came from Crop King. But anyway, that will miss the water on the roots. So we just did a small one last year, and so this year we're going to try a bigger one and see how it goes. But it worked pretty good last year, so we kind of made our own instead of paying a couple of $1,000s for one that you get from the Kellogg's. Let's see, what was the other question? The hydroponics setup. Our high school has a hydroponics class, and they came down actually and helped me set that up. But we have our beta pots, and we have a pipe that goes through. We plant peppers and tomatoes and cucumbers, tomatoes, cucumbers, peppers, and lettuce. We do lettuce. And we've been really successful with that. We've had a few problems along the way, but, you know, we work them out. But our high school helped us set that up. Then we have the, I can't think of what they call them now, but they're like a tray that has the hole in them that has the betta pots that sits inside them. And so we have that for our lettuce.
Okay, well, that's actually an area that in our matrix we're looking forward to adding more things on hydroponics and aeroponics. And in fact, we're working on a lesson right now that's going to integrate the aeroponics with Arduino board so that kids can develop a timer to know when it needs to miss the roots and that kind of thing. So something to keep your eye out. I see there's been some other posts, and you can find lots of resources online for making these hydroponic units. And aeroponics is something that's a little more even more techy, if you will, to see what a STEM or see what plants need, and you can integrate STEM through using science, technology, and engineering, and of course math, to keep the plant alive. So thanks for sharing that. You can continue to post some questions to Deborah if you'd like, and then I'd like to now jump forward and show Jessica's video. The link is going to get posted here in just a minute. Carolyn, you should be able to go watch Jessica Pittman's video.
So I have a URL in the chat window, and I'm going to set the buzzer for about 3.5 minutes.
I actually have a question about how much your hydroponic or aeroponic, I guess your growing structure there, how much did that cost?
Well, we were very fortunate to have received a grant through the Virginia Foundation for Agriculture in the Classroom of $500, which got us started with the Tower Garden. The initial cost, well, with the kit, cost $545. So we were able to get it going. With that came with everything, seeds, pump, everything you need. Then the following year, I did a little bit of sort of personal fundraising, and we purchased the light kit that you saw in the photos. And the light kit enables us to grow year-round in the classroom. And that was another $500 to get the light kit.
There's some other questions down here, and while you're looking at that question about the light source, I have seen some folks building these in 5-gallon buckets. So we're actually using that as we investigate an aeroponic and linking that with Arduino boards for programming for students here at the National Center that will become part of the curriculum matrix. So it's good to know that we will be definitely below the $500 mark, but we want to make this something that students can really engage in problem solving, like how could I grow this lettuce, and what does it need in terms of science, and what's the engineering and technology that goes into this type of setup, vertical farming or hydroponic farming. So there's a question about light, and what else?
The light kit that I have on the outside of the Tower Garden actually came from the same company that we purchased the kit from originally. It's a company called Juice Plus. Also, the lettuce that you saw that was being grown there, not only do we have the salad party, throughout the year we grow lettuce indoors from August to February, and the students, we of course graph the data and plant and all that good stuff with the Tower Garden, but when it's ready to harvest, the students actually harvest the lettuce weekly, and we sell that to the families and staff in the school to earn money to continue our project.
Okay, well, very good on that. And again, if you just keep rolling through questions, and in fact, this next couple of slides, I built in some pause time here for any other questions that you might have. Of any of the 4 teachers that you've seen, I think they're an inspiration to me about how much these activities that they do and how well they are able to integrate them into all areas of their curriculum. So we have our names posted on the NSTA website. We're also, I think you can get our emails there. If not, we'll make them available. But please ask questions of these teachers. They've been successful with their students. And I think all of them would say that they had a good time and felt like it was a really good learning experience, and hopefully we're able to contextualize the things we're talking about with three-dimensional learning. So we'll just leave the chat box open. I don't see anything else new so far. And I think we'll go ahead and roll into the next section here, which is looking at some of the other standards inside of science and some of the practices. Tiffany Maxey is going to talk about a couple of different science lessons for grades 3-5, and so I'll turn it over to her. And you might know, before Tammy starts, so you might notice that it says it's the curriculum matrix, but it's green, and that's because on the Virginia Ag in the Classroom site, they've integrated the Ag in the Classroom matrix. So if you go to her website, it just comes up in a different color scheme. And in fact, you're from states all over the country, and each one of your states has a state contact, and on the national page you can find out who that is, and you can visit your state's website by just doing agclassroom.org/, in this case it's VA for Virginia, or you could do /KY for Kentucky or /CA for California, and learn what your state has going on. But many of the states connect to this curriculum matrix, and if they don't, you can always just stay at agclassroom.org and search the lessons from there, which I hope you've been doing, and we're going to actually practice in a little in a minute in a different browser that you'll be able to search some things. So Penny?
Thanks, Deb. I'd also like to point out on this slide, you will see a binder there, and you will also see our search button. With Virginia's program, we host our own lesson plans, and we host National Ag and Classroom lesson plans. So when you come to our page, you'll see a little both. That allows us to use our state standards and national standards. Virginia is a state that does not comply with Common Core curriculum. We use other standards. The lesson that I have for you highlighted tonight, this one is one that we conduct a lot of time in our educator training sessions because it is a lab. Teachers need examples of how to use labs with students, and so this is a good one. When we look up corn, you'll pull up Corn Amazing, corn, fuel, food, and plastic. There are 3 portions to this lesson. The first portion is the history of corn. There's the
Tammy, let me interrupt you a minute. Could you try to get closer to your microphone? It's a little bit garbly and a little bit feedback.
Okay. When you pull in, you're going to see our first activity, which is the history of corn. The second activity, which you will pull in, is talking about renewable versus non-renewable energy resources. And you can take time there and talk with your students about what pieces are renewable and which ones are non-renewable. But then the highlight of this lesson is to make corn plastic and to talk about how that's safer for the environment, doing a little bit of reduce, recycle, and reuse there. I have highlighted pictures here from that lesson where we're working with students. And the way you make corn plastic, the simple way that elementary students can do that is you use 1 tablespoon of water, 1 tablespoon of cornstarch, and 2 drops of corn oil. Just for fun and giggles, you can put in a little food coloring. You're going to then talk to them about different pieces of the scientific method. We're going to make a hypothesis of what's going to happen here when we add heat to it. Then for your lab, you're going to have them go through and microwave your mixture for 20 to 30 seconds. What happens there is you're going to have a chemical change take place. You can see that there in your slide that that's going on. We have discovered when you do this, immediately it's going to be extremely hot when you take it out of the microwave. But you will also see there that it's very flexible and pliable when you take it out of the microwave with students. It's great to drop one of those into a glass of water and see how long it takes it before the edges begin to unravel. But with another one of those, it would be nice to put it into some sort of mold and leave it overnight. You will find it gets very tough, and you can talk about the porousness of how that's going to affect things. In addition, we'll usually, when we talk about reduce, recycle, and reuse, we'll use styrofoam packing peanuts and then biodegradable packing peanuts and have them ask what's going to happen when you put both in a glass of water, put them in a glass of water. You'll see the biodegradable made completely of cornstarch dissolves in a few minutes, whereas your styrofoam when it takes longer. When we're working in here with this lab, again, we teach the various of the recycles. We also teach in this one the use of the scientific method. Yes, 1 tablespoon of water and 1 tablespoon of cornstarch. The oil is usually about 2 drops of corn oil. Look for that. The lesson is located both on the curriculum matrix. When you type in corn, you're going to come up with the corn plastic there. And some of these images right here are from the lesson you'll find on our curriculum matrix. So that one is showing you the scientific method using chemical change. The next lesson I have for you to highlight is the physical change lesson. This one is very forgiving whether you're going to use it for a social studies application or a science application. We do both. What you have here is an example of butter that is made. It is a great lesson, again, to do with children. There's a link there. You can do physical change or butter on the curriculum matrix and come up with these 2 lessons. You can talk to them about why do we need to put some type of clapper into a container if we're going to make butter. And you can experiment with your students. Again, you can use your example there of, do we need heavy whipping cream or can something else suffice? So we can test different variables. We can test different questions with our students with that. So you're going to see there, that one is the example that you have there is where butter has been made. The next piece we have with this, that's actually pulling up that lesson, whipping butter into shape. From there, we also made a foldable to write up, and if you'll look at that foldable very quickly, you'll see that you can have all the different pieces of the scientific method there for your students, that basic teaching tool there with them. I would recommend as you find these lessons, rather than search them each time, create your own binder and put them in there. I'm looking to see if I have questions for you, and I'm going to turn it back over to Deb for the next slide.
So hopefully some of you are following along. We posted the links in the chat to the two lessons. The first one was corn plastic, and the recipes for making those and putting the plastic bag into the microwave and having the kids create that. And Tammy talked about, doing it as, is this a chemical or physical change? This is discussed in the lesson, and putting water back into it. I've also had students create them and dry it down, make it very hard, and then they realize, wow, the properties of this have really changed, and you can drop it and it's like shatters like glass. And so all kinds of different types of things that can be learned from doing the corn plastic, in addition to the things that you mentioned there. And then the whipping butter into shape was also posted as a link. But what I really hope is that you have a browser window open, maybe next to this one, that you can actually click on these links and scroll through the lessons in somewhat real time and see some examples about how these are written out. We've used the 5E model that's also used by the NSTA publication, Science and Children, Science Scope, and Science Teacher. Using the 5E models for exploration, the explanation for engagement, and so forth. And so you'll see that played out in each one of these lessons. So what we're going to do now is let you have your turn. Go to agclassroom.org, and when you, in the bottom left corner, or you can just go to agclassroom.org/matrix, and it'll take you right to the matrix page, and do a keyword search. Put something in there that maybe right now, this time of year, you're doing something with apples, or you want to look up something about chicken or egg. Maybe does it come first? I don't know. But chicken or egg or flowers or bees or inherited traits, seeds or model or genetics or wheat or something like that as a topic. And we also have some, if you search certain strategies, we have teaching strategies that people want different keywords like cause and effect. You can try those kinds of things. And then depending on your grade level, you can make those checks. If you're looking for science, great. Maybe you're saying, I'd really like to find something that does both, or I'm really looking for less on health and nutrition. You could put it there. So take a second here on agclassroom.org/matrix and do a search. Because in the next slide, what we'd really want you to do is tell us what you found. And I'm going to share some of the things that we find and use often and maybe have the biggest hits inside of the matrix when we look at our Google Analytics. But when you come back here, you find a lesson or something that you found, you searched one title and put it up, come back and post here. We're using that, I think it's called the text box tool, Carolyn, and just put the title of what you found during your search.
Thank you, Deborah. I made the toolbox available to you, and it's the fourth icon down. It has a letter A on it, so feel free to come back and text what you found on the whiteboard. I set the buzzer for the timer for 1 minute and 30 seconds. Looks like they're finding a lot of great stuff, Deborah.
Just wanted to have some fun to see what is there and that we continue to add. I hope that while you're looking at those lessons and you're scrolling down, and I was just looking at the whipping butter into shape lesson on the bottom. Of course, there's sources that we have taken some of the materials from, but the book links, and some asked, where do you get Who Grew My Soup? At the bottom of the lessons now, you may have noticed there's links to either order them directly from the Ag Classroom store or out to some other source where you can order those items. Also, there's links to YouTube videos, posters, all kinds of kits, and just easy things for you to get a hold of, whether it be online or inexpensive to order. That's actually one of the rules. There'll be no expensive stuff on here. That's something that's more of a commercial, but really something that's in a price range for teachers to get either the support of their school or the support of their community to do those kinds of activities in their classroom. And yeah, there's a lot. Simple Machines, great. Apple Science, oh yeah, I like that one too. So I'm glad that you all are in here searching and finding these different topics and titles. And, you know, just continue to kind of use this and experiment. Of course, I had a teacher the other day who said, I just said search all. That was a lot. so you can do that as well as you scroll down through. If you say, I want this grade level, just science, scroll through it and see all the different types of lessons. Maybe there's something there you thought, oh, I hadn't really thought about covering that. And if I can just, that's great. We'll probably stop putting those. Just want to get you engaged with that. With the searching on the matrix to see how easy it is and see all the different links that we have that make it really easy to contextualize science through something that's very familiar to students. And for example, if you searched egg or eggology, it's one of the lessons that came up. It's a very popular lesson in the curriculum matrix, and it's really learning all about eggs. And if we have the purpose at the beginning, students will identify the basic needs of growing a chick to meet during the egg incubation, and lots of you may have done this in your classroom, but this puts together quite a few resources to make it a really tight lesson plan, but also be explicit about some of these three-dimensional learning topics we've talked about. And on the bottom, you may have also noticed the education, content standards, common core connections, and the ag literacy standards that are at the bottom of each lesson. I also found, I searched wheat at one point, and this was on wheat germ DNA. And this is very small font right here, but it's just to point out, you know, these are underneath activities, what you would see, activity 2, the wheat germ extraction, and then also over here you might see that we also have some assessment kinds of things with Kahoot games and some electronic tools that would maybe enhance or really provide a review for the students of the different content. Another lesson that is quite popular is called My Farm Web, and it's really connecting everything we use every day, like we just talked about here on this outer ring, back to the farm, which both Amber and Tammy talked about. This is a really fun one to do with K2. Get down on the rug, you connect them with yarn, and each person has a picture, and they're trying to figure out where to put it and how it goes off. And you can have a conversation about how each one of these is grown and how all of them use some different types of science. A lot of different people have to be involved to get that particular product to you. So My Farm Web is another one of the lessons that's inside of the matrix. Tammy already mentioned this too, but this is the submit a resource, and she talked about My Binder, and that's a really good way to, when you find something that you really like that you want to be able to use again, maybe it's making the corn plastic. When you click on My Binder, if you've made one, and you just click on My Binder, and it'll say create a login and a password. That's it, so you can return later. The lessons as you're going through, you may have noticed there was a link that said add to binder, add to binder, add to binder. So on each lesson, you can just click add to my binder. And if we make changes between the time that you've added that, maybe 2 months ago, 3 months ago, a year ago, when we find new videos, new kits, we revised the lesson, we found a typo, we've added a new resource, it will automatically be updated because these things are kept in a cloud online. So if you create a binder and then add that resource to it, it's always there for you, ready to go, and it's always updated. If you have fantastic lessons, I've seen some great ideas presented here down in the chat window. Hey, submit it. Submit it. Be published on our site. If it connects to agriculture and will contextualize science concepts within something related to food, clothing, and shelter, we would really love to see it, give you some feedback on it, and make it really meet the educational standards that are noted there at the bottom of each lesson. And so that's a little bit of a plug for how to use the binder and store your resources so that you don't have a lot of paper and print out, and you also get all the updates when they come. We're wrapping up here. Do we have any questions about using that resource? Let's see if there's some comments. This is great. This is fun. Good. Continue to have fun. Continue to give us some feedback. I just want to, we're kind of wrapping up here on time, but I want to make a statement coming back to the phenomena that we've been talking about. Consider the questions of children that they usually start with why do or how come. And they're things that are quite concrete. Sometimes they're things that are invisible and maybe more abstract, and those are the ones that are really hard to explain. But if you have a way to contextualize that particular phenomena by something they're really connected to or can understand, that is something that they'll go, oh, aha, I really get that. I know what that is. I know what that means. And, of course, they can go explain it to their friends and their parents and have some real self-esteem kind of moment where I know how things work. I really can understand how come or why do. So these questions about phenomena are really the beginning of a way of knowing, and that is that we started with a way of knowing for science. Our web page, again, I'm going to show right here. You can start searching from there, or you go right to the matrix resources. Every month, when I put this slide set together, it was August, so now it says September, and soon it will say October. We put new featured resources here, and you can see what's happening. We chose the InterAgtion with 3D learning, and there's a nice website right here, the Responsible Acre. I think those folks are letting us use their image because I really like the idea of it as being 3D or three-dimensional type of learning. But they have a really cool website, the Responsible Acre, that as you scroll through it is a neat animation about how the different layers of agriculture go together. So I encourage you to take a look at that. Any other questions as we wrap up? Comments from any of my other presenters?
Thank you so much, Deborah. And after we wrap up here, they're welcome to stick around for a few more minutes to ask you some more questions. But a huge thank you to our InterAgtion experts, Audrey Harmon, Tammy Maxey, and Deborah Spielmaker. And a special thank you to our InterAgtion teachers, Amber Bales, Jessica Pittman, Tiffany Porter, and Debbie Steen. Thank you for such a bunch of ideas and information for integrating agriculture into our classrooms. I'd also like to thank the organization National Agriculture in the Classroom and the National Center for Agricultural Literacy for sponsoring today's webinar. And thank you also to the NST administration for their support for web seminars. This concludes our program.